So we're going to look at Unit 4, Lesson 1, Activity. We're going to put this function into our graphing calculator, and we're going to look at this activity. We're going to put this function in our graphing calculator. We're going to use the table feature to fill out these outputs for these particular inputs. So let's give that a whirl. Put that guy in, fill out the table, and we'll see what 1.875, 1.9 is 0.079. This is 8 e to the negative 4. That's close to 0. This is 0. Well, daggone, we know that has to be 0 at 2, because 2 minus 2 is 0, and so you know it's going to have an x-intercept at 0, correct? But look what's happened. Right here, I'm to the left of 2. Correct, I'm a little bit to the left of 2. I'm at 1.99. And so let's go 2.5 was 2.125. This was 0.081. And this was 8, again, 8e to the negative 4. Okay, so as I approach 2 from the left, okay, what happens to the outputs? The outputs approach 0, correct? The outputs get closer and closer. The outputs approach, as I approach 2 from the left, the outputs approach 0. As I approach 2 from the right, again, the outputs approach 0. And we would think that that would happen. But what I want you to see about this, what do we know about the outputs close to 2 from the left? They are what? What do you know about these outputs right here? All of the 1.875 is positive, correct? Less positive. Less positive. The values are decreasing to 0, but they're positive. Look what happens when this side here. They're positive. Positive, positive, they still approach 0. So if I'm near x equals 0, if I'm near or x equals 2, the outputs are always what? Positive. And that doesn't make sense. That's the first time we've ever seen that. Usually when you have an x-intercept, you go positive to negative or negative to positive, right? The x-intercept, right? You cross the x-intercept. You cross the line. This is the first time. Oh no, we saw some of these in quadratics. So if the vertex is on the x-axis, what happens? If you have a quadratic and the vertex is on the x-axis, what happens to the quadratic? It comes down, hits the x-axis, and pops back up, right? And that's the same thing that's happening in here. If I only look at this part right here, if I only just for a moment look at this and think about perfect. Better order one of them dudes as quick as possible. What the heck was I talking about? Okay, so if I only talk about this guy right here, if I'm only looking at that, and that were quadratic, that thing would bounce at x equals 2. And that's exactly what's happening here. As the inputs get close to 0, 2 from the right and the left, the output or the function never become negative, right? Never become negative. They're always positive. So if I just, let me see where I am with this thing right here. Well, we could graph this pretty quick. Hey, what are the x-intercepts of the function? The x-intercepts of this function are negative 6 and 2, correct? So let's plot this. Negative 6 and 2. Let's graph this bad boy. Let's go negative 6. Let's go 2. This is the x-intercepts. Negative 6, comma 0. and 2 comma 0. What's the y-intercept of that bad boy? If I put 0 in, what would the y-intercept be? Do you know? What is f of 0? Anybody? 24. 24, because it's going to be 4 times 6. That's 24. You could do that with your graphing calculator as well, but it's easy to see. If I put if I put 0 in for x, I have 6 times negative 2 squared is 4. That's going to be 24. So this y-intercept is going to be 0, 24. And if I want the end behavior, if I were going to multiply that out, I'm not going to, but another way to write this function would be this, true or false. I could write it this way. I could write it as x plus 6 times what's the graphing calculator that uses the RAM? I don't know. Probably is, because the graphing calculator uses a lot of RAM. Let's see if this helps. I think that helped a lot. I don't know what's going on with this. That's a great 2. I should just be taking off today, but I could be going. All right. Let's see if we can't get what's going on today. Okay. I'm actually videoing all that. That's funny. It's not that funny, but it's kind of funny. There you go. Isn't that what f of x would look like? X plus 6 times x minus 2, x minus 2. And what would the power function be? If I were to expand that, that guy would look like x cubed, correct? Plus, we don't care about what's in the middle. And we know the y-intercept is 24. So therefore, we know what's the end behavior. It's a cubic. It doesn't look like a 3, but it is indeed a 3. That's the new digital 3. So that is a 3. The leading coefficient is positive. So that bad boy starts negative and ends positive. We're going to have to be very creative when we write questions about that, because you can put this in your graphing calculator and find it. What I would look for is some really crazy numbers so that you really have to expand the window. That's why you won't be able to use Desmos. You got your graphic calculator, right? Because Desmos really easy to do that. So this guy starts negative and ends positive. So let's graph what we know. It has a y-intercept, 0, 12, correct? And it has these x-intercepts. It starts negative and ends positive. And now we're going to sketch the graph. We don't know where the maxes or mins are. The polynomials are smooth and continuous, so it has to come here. It has to go through here. We don't know where this min or max is. We'll just make it to the left of that. And then look what has to happen at x equals 2. It can't cross the x-axis, can it? Because there's only 2 x-intercepts. And we're going to talk about that a lot with rational functions. There are only 2 x-intercepts, negative 6 and 2. This thing absolutely starts negative and ends positive. And if we notice from our table, this thing the outputs get close to 0, and bam, and it bounces. And so that's what's going to happen with this guy right here. When you have one of the terms to the second power, it's going to bounce. In fact, if you have a term to the even power, it bounces. If this was cubic, it would go through it. So this is called, 2 is called a double root. There's only one 0, but there's actually, we think about it, mathematicians saying, this thing has 3 zeros, -6, 2, and 2. It has 2 zeros because of this guy right here at 2. We call it a double root. You don't have to worry about the whole double root thing. you just have to know it bounces at 2. Let's see, what else can we? What happens at 2? It bounces, graph bounces. And let's see if there's anything else on this particular activity. Okay. Don't use our graphing calculator. It's I have 5 minutes. So real quick. So let's look at this bad boy. The first thing I'm going to do is look at the power function. Let's act like we're multiplying this out. What would the first term be? Anybody? X to the 5th power, very good. Plus, we don't care what's in here. And what would the last term be? Morgan? -10. Oh, -2 times -2 is 4. Oh, it would be +20. Because this would be -2 times -2. And if I did write it out like this, let's see if my calculator or my computer can handle it. Trust me, I have as much RAM as I can possibly have in this thing. I don't know what's I might have a bunch of crap working in the background. I'm gonna have to check that. That's a great. If I would expand it, look, I have what? -2 times -2 is 4, so it's going to be 20. So it's going to have a y-intercept. And we know the x-intercepts. The x-intercepts are going to be -5, 0, -1, 0, and 2, 0. What's the y-intercept? 20. Let's graph those bad boys. I have -5. Bam. I have -2. Bam. I have -1, or I have 2. I have -1, and then I have 2. And then I have a y-intercept of 20. What's the end behavior of this bad boy? Leading coefficient positive, degree odd, starts negative and ends positive, correct? So this bad boy is going to start negative. Whoop. It's going to end positive. And now let's see if we can sketch the graph. It has to come up here. Does it go through -5? Or bounce at -5? Goes through. At -1. Does it bounce or go through? It has to bounce, because if it goes through, it would have to hit this y-intercept, and it can't. The y-intercept is at 20 up there. So it has to bounce. So it's going to bounce here, and that's a minimum. Bounce. Come up here. It's going to go through. But then what has to happen? It has to come back down and hit this x-intercept, doesn't it? And it has to do what? It has to bounce. So this whole Unit 4 Lesson 1 activity was about bouncing. It's about when the graph bounces. And here's just a simple question. What allows you to sketch this graph without lifting your pencil? It's continuous, correct? Could you answer this question? Could you answer when f of x is greater than 0? Whenever x is greater than -5, but it's not 0 at those values. So you couldn't include those values. We won't be asking a question like that. But I think that, without your calculator, could you name the minimum points? Believe you me, we can be very creative with a problem like this that you can't use your calculator. So let's talk about this. How can I write a question like that? where the graphing calculator wouldn't be useful. Janelle? What I could do is just like I said, that other problem where